Okay, so I think without further ado, I'd like to invite our first speaker, Setareh GHALAMESTANI from Sirris, and also Cedric from DAMEN to present the market study.
Good morning, everybody. My name is Setareh GORJI. I'm from Sirris. I want to present you the market study for offshore and marine industry. This was in fact done together with DAMEN company. We mostly focused on the application in offshore, and DAMEN did the study for marine industry. I start the presentation, and at the end I give the word to Cedric VERHAEGHE from DAMEN to continue with the application in marine industry. The objective of our market study, our deliverable, was in fact to give an overview of the advantages and current challenges of adhesive bonding, to present current application of adhesive bonding in offshore and potential future applications, and to present adhesive bonded hybrid joints in shipbuilding together with some case studies. Here I have highlighted some of the advantages of adhesive bonding, technical, design, economic advantages. So regarding the technical advantages, we can say joining dissimilar material, corrosion reduction, adhesive bonding can act as a sealant. In fact, it can improve the fatigue performance of the joint, and it can act as a damping vibration. Looking at the design advantages, it enables us to create complex joints. We can connect very thin materials or very small parts. And some word about the economic advantages. It can save the construction time, and because we have less corrosion, less fatigue, we also need low maintenance, which can reduce the cost. There are also some challenges, and that's why Qualify project was started. A shortage of design data regarding durability, disassembly of the joint. These are some of the challenges. We need some curing time, some drying time for the joint. Well knowing the design joint strength in advance can be sometimes challenging. Some additional time and costs are needed for the surface preparation, perhaps some extra costs related to safety, working condition, and the environment. Adhesive bonding has been used in many sectors. The focus of our market study was for the maritime sector, but in fact it was used in many sectors. For example, the air sectors. This was one of the pioneer sectors for the application of adhesive bonding, although they have very strict regulation. It was also used in the rail sector, civil engineering, construction, automotive, and so forth. What you see here is an example for a bridge which was built in Utrecht. It was a long bridge, 140-meter long. It was the first bridge with combination of composite and steel. So the deck was made in composite and the frame is a steel frame. Adhesive bonding was used for the joint of the composite and steel, but because it was the first experience, they also wanted to make sure that the design would perform well regarding the lifetime, so they added some pinhole connections. The technique of the design, it was from Infracore company. You see two other examples of adhesive bonding in other sectors. On the left side, you see a design from Tankfell company. It was a hybrid composite tank solution, in fact. So the tank is in composite with a steel frame, and the joint was done with adhesive bonding. It proved to be advantages. It was the lightest design. It is the lightest design in the world. And the advantage was that with the application of adhesive bonding, the forces are more uniformly distributed. This means that we avoid local peak, high peak stresses. On the right side, you see an idea. It was studied for the structure of the bus. So normally the connection is, the design is in fact in steel with welding, but they thought of adding composite and adhesive joints between the two materials. This was because, in fact, with welding, you have a high risk of fatigue and crack in the design. So with composite and the adhesive bonding, it was a very flexible joint, meaning less fatigue, less damage to the design. And it was also a lighter design compared with the classical designs, which means that also less fuel would be needed, which would reduce the cost. This is also one of the most important advantages of hybrid design joints and adhesive bonding in marine industry, because it can significantly reduce the fuel consumption. In the framework of Qualify project, we developed a survey to map the current position and the market potential for the application of adhesive bonding. Although the focus of our report was for maritime sector, but we addressed it to all sectors. We had like 73 participants, mostly from the Netherlands, Belgium, France, and Germany. On the left side, you see the organizational categories. So we had something like 45-46% from marine offshore oil and gas, which is the focus group for our market study. So something less than 50%. And on the right side, you see the organizational type. We had 44% of the participants from the SMEs and 33% from large enterprises. So a good feedback from, in fact, the industrial sector. One of the questions we asked to the participants was the criteria for selecting a joint method. And in fact, it was shown that the lead time of assembly is the most critical factor for the selection of the joint. 53% voted for this. With much less votes, the next was the cost of the material and reliability. And 47% said that they already apply adhesive bonding for high-risk structural joints with or without mechanical fastening. I mean only purely adhesive joint, or for example, with similar to what I showed for the bridge in Utrecht, with adding some mechanical fastening. In this case, it was pinhole. These are the responses from only the maritime sector. We also asked them about the advantages of adhesive bonding. They also said that ability to join dissimilar material, design flexibility, faster production or installation time are the biggest advantages. We asked them about the roadblocks for the application of adhesive bonding, unclear regulation and certification requirements. This was one of the roadblocks, required testing campaign and risk of failure due to aging, lack of long-term performance data. These were reported as the biggest roadblocks. Concerning the objectives of Qualify project had three main objectives. So the durability of adhesive bonding, regulatory requirements, inspection and maintenance. We asked the participants to address the biggest issue for each of these objectives. So for durability of adhesive bonding, the biggest issue is in fact lack of data. For regulatory requirements, the biggest issues are structural requirements and fire safety, which was not within the focus of Qualify. Inspection and maintenance, the biggest issue is lack of a reliable inspection protocol. Next, I want to present some of the application of adhesive bonding in offshore. First of all, about the wind turbines. Adhesive bonding is already used for the wind turbine, for the design and for the assembly. So in the internal structure of the blade, you see the application of adhesive bonding. This is shown in the figure on the left side. And the joints with adhesive are marked with light gray. It's also used for blade assembly, blade segmentation. What do I mean with that? Economically thinking, it's better to have less units, less wind turbines in a park, in a wind park, which are bigger. Then you can produce the same power, same energy, but with less cost, in fact. But the bigger turbine means that the blades are also longer. This would be a challenge for the construction and for the transportation. To this end, they build them in segments and then they do the assembly. It can be segmentation in the length, in the width, in the height. So one of the application of adhesive bonding is to join these segments together. And the last one is for the connection of the blade to the root. So once the blade is completely built, you need to attach it to the hub. And there again, there are also some techniques, the flange type, the T-bolt. One of them is the stud root connection. And for this type of joint, they actually glue the studs to the hub. The next application of adhesive bonding is for the repair or in fact for attachment of a reinforcing plate without application of, without doing any high temperature like welding, for example. That's why they call it a cold repair. This is in fact a very suitable method for marine and offshore application. There are some solutions available in the market. What you see here is a solution of cold pad company. They call it the cold sheet solution, and you see an example how it is attached to the surface. The next application of adhesive bonding is in fact for bonding fasteners. So this is an idea to reduce drilling holes. So for some joints that you don't want to drill several holes, then you can use adhesively bonded fasteners. There are many solutions available in the market. What you see here is an example of the click bond company. They call it studs. It was used in an offshore oil platform. The last one that I want to present, the last application, is in fact a potential future application. We know that for the platforms, the oil and gas platforms, offshore platforms in general, they use some composite grating. And these gratings are connected to the steel frame, so the metallic frame. Currently, the joint is with clips and clamps or mechanical joints, but potential application would be to use adhesive bonding. So this is one of the applications for future. I give the word to Cedric to continue with the application in marine industry.
Thank you, Setareh. So our next speaker will be Cedric VERHAEGHE from DAMEN.
I'm now going to give 3 examples of bonding in the maritime industry we at DAMEN are currently applying or investigating. The first application is something we've been doing for some time now at DAMEN, which is the bonding of small equipment inside and outside of the vessel. For these cases, bonding proved to be a time and effort-saving joining method, since there is no damage to the structure or materials on the other side. These are generally applications with high safety margin and low consequences, for which we did some small-scale tests at the start, standardized the process and design, and can now be applied after small hand calculations. The second case I'm presenting is something Damen Gorkum has been further developing based on the experience with small case applications. This is the bonding of a window near the intact stability waterline. This again avoids hot work, resulting in lower stress concentrations and a cleaner solution. But since this is critical to the intact stability, this was closely monitored by Bureau Veritas. Together with the supplier of the adhesive, Sika, DAMEN performed a set of dedicated tests to demonstrate the performance both structurally as with regards to watertightness. And the final case is the qualify case. This is something that DAMEN Naval is very interested in. And this is when we were considering a composite superstructure to be bonded onto a steel hull. Since composites cannot be welded, we can either bond or bolt the structure to the composite, to the steel hull. And we have chosen for bonding, since this does not require any structural modifications to the composite itself, requires less labor, and reduces the maintenance over its lifetime. The approval of a joint in a primary structure exposed to seawater and significant loads does require a thorough understanding of the loads, behavior of the material, and manufacturing quality. This is why we joined the Qualify project, to be able to set up such a knowledge base together with the other partners such as Bureau Veritas and Lloyds. And this case will now be further explained during the rest of the day. Thank you very much.